The focus of this lesson is on graphing a logarithmic function, and we have the function f of x equals the natural log of x, which, again, just to remind you, the natural log is just the log base e of x. And that's always helpful just to kind of see that base written in. Now, as far as if you had to graph a logarithmic function, it's basically the inverse of an exponential function. So for an exponential function, you would pick your x's to be -1, 0, and 1. Well, for a logarithm, you would do the same thing. You'd pick your y's to be -1, 0, and 1. And then what you would do is what you're really saying is -1 is your log base e of x. So to determine your x, you would convert, and your x would end up being e to the -1. And so your x ends up being your base raised to your power. So 1 over e, which is 0.37 approximately. And then the same thing, if you want to determine the x that pairs with 0, just take e to the 0, which is 1. And if you want the x that pairs with 1, you take e to the 1, which is just e, which is approximately 2.72. So that's how you would plot the points that you would end up needing to graph. So you would graph 0.37, -1, which would be approximately here, 1, 0, and then 2.721. And you would get a graph that approaches that y-axis but never hits it, so it kind of just follows it down. So there's a vertical asymptote at x is 0. Now obviously if there was transformations that may change, but that gives you the graph. Notice that the domain for this particular function, it starts at 0, non-inclusive, and goes to infinity, so that would be the domain. And then the range for all logarithmic functions start from -infinity up to infinity. You hit the entire range. And then, like I said, the vertical asymptote is x is 0. And then your three key points are always going to be of the form your base, comma 1, your base raised to the 0 power, comma 0, and your base raised to the -1 power, comma -1. So just keep that in mind. Basically the points of the logarithmic function are the reverse of the points of the exponential function. You just swap the x's and the y's, which makes sense since they're inverse functions. Domains and ranges swap.